Ever felt that nagging ache or, instability after a shoulder injury, especially right up top near the collarbone?
Mm,
If you're active at all, lifting, throwing, even just reaching these AC joint injuries, well, they're incredibly common.
they really are.
And getting that joint properly stable again so you can get back to doing what you need to do, that can be a real challenge sometimes.
Absolutely. That junction where the collarbone meets the shoulder blade, it's critical. Any instability there really impacts the whole arm's function. Pain, weakness,
Yeah.
it lingers.
Exactly. And that's precisely what we're diving into today. We're looking at a really interesting approach for fixing these tricky injuries.
Okay.
It's a surgical method called the triple anatomical technique for AC joint reconstruction.
Right.
Our source for this deep dive is a technical note, quite recent actually, published in Arthroscopy Techniques.
Ah, yes, I'm familiar with that paper. It outlines a very specific way of doing things, doesn't it?
Mhm.
Aiming to restore the joint's natural structure, perhaps more completely than some older methods might.
That's the idea. So our mission today is to break this technique down, look at the different parts, and really try to figure out why this specific combination is being seen as a potentially big step forward.
For restoring function and maybe even speeding things up a bit for patients?
Exactly, getting you back to action faster. So this triple anatomical technique, the name itself gives a clue, doesn't it? Rebuilding it anatomically in 3 key ways. How do they actually start?
Well, they begin right at the foundation, you could say. The deepest supports, the corticoclavicular ligaments.
Okay.
You can think of those as the main anchors holding the collarbone, suspending it from part of the shoulder blade called the coracoid process. They give that crucial vertical stability.
Right, stopping it from riding up.
Precisely. And in this technique, they use a synthetic graft to reconstruct those ligaments, very specifically placed where they naturally sit.
Okay, so a strong man-made material for that key vertical support, replacing the original ligaments. What's the next layer then? What do they build on top of that?
So once that sort of vertical stability is secured, they focus on the acromioclavicular ligaments themselves. These are right at the joint line.
Mm-hmm.
And these are more about horizontal stability, stopping that back and forth movement, and rotational control.
Right.
Now, instead of using another synthetic graft here, the technique does something quite clever. It uses what's called a coracoacromial ligament transfer.
A transfer, so moving tissue from somewhere else.
Exactly. They essentially borrow a nearby ligament, the coracoacromial one, and repurpose it to reconstruct the damaged AC ligaments.
Mm.
It's using local biological tissue.
Ah, I see. So it's a good biological match, presumably, for the forces right at that joint.
That seems to be the rationale. You've got the synthetic for the heavy lifting vertically and this biological transfer for the finer control at the joint itself.
Okay, that makes sense. Synthetic below, biological transfer at the joint line. That's 2 parts. What makes it triple? What's the third element?
The third component involves repairing the delta trapezial fascia.
The fascia. So the covering layer.
Yes, exactly. It's that thicker layer of muscle and connective tissue that sits over the top of the joint. Repairing this adds another important layer of structural integrity.
Mm.
It provides extra mechanical support.
So it really sort of seals the deal, reinforcing the whole area.
It completes that anatomical picture, yes, reconstructing the entire functional unit.
So the real innovation here seems to be less about just adding steps and more about the specific combination. You've got the durable synthetic for that initial vertical load, the local biological transfer, which might integrate better right at the joint.
Potentially, yes.
And you're shoring everything up by fixing that overlying fascia. It's a layered approach, isn't it? Targeting different aspects with different methods.
Precisely. And that's what aims for this truly comprehensive anatomical repair. The source does highlight that this specific combination is described as being safe and, importantly, reproducible.
And effective.
And effective, yes.
Yeah.
At restoring that crucial joint stability. Yeah.
Okay, and this is where it really matters for you, the listener. What does achieving that kind of robust, multi-layered stability actually mean for someone recovering from this injury?
Well, having that really strong, stable fix right from the start, it can be a bit of a game changer for rehab.
How so?
It allows for controlled, early movement during the rehabilitation phase. Think about how frustrating it is to be stuck, immobilized for weeks on end.
Definitely.
This technique is designed really to minimize that period. Because the repair is initially more stable, the physical therapist can often start guided movement much sooner than they might with perhaps less secure repairs.
And that ability to start moving, start working the shoulder earlier, That must translate directly into the recovery timeline.
Absolutely.
Yeah.
It supports, or certainly aims to support, an accelerated return to function. For athletes, people in manual jobs, or really anyone whose daily life needs a fully working shoulder.
Which is most of us.
Indeed. This technique is geared towards speeding up that whole process significantly, getting them back to their activities, whether it's sport or demanding work, more quickly and hopefully more confidently.
Okay, so to summarize then, this triple anatomical technique is presented as a comprehensive strategy for AC joint repair. It combines synthetic grafts deep down for vertical stability,
Correct.
a local tissue transfer for the horizontal stability at the joint itself,
Yes.
and then a fascia repair over the top for overall reinforcement.
That's the triad.
And the promise, according to the source, is a method that's safe, can be done reliably, and achieves really solid stability. And that stability is key because it paves the way for earlier rehabilitation and ultimately a faster return to whatever you need your shoulder for.
That's the goal. Restoring that complex natural stability is really paramount. It's not just about making the X-ray look good. It's about getting the function back.
If you found this deep dive insightful, perhaps share it or leave us a quick rating. It genuinely helps other people find the show. And just as a final thought, considering how this technique cleverly uses different materials and targets very specific anatomical structures to get that natural function back, what might this suggest for the future? Could we see similar layered, material-specific approaches being used for other complex joints, maybe setting new standards for accelerating recovery elsewhere in the body?
It's certainly an interesting thought, that principle of combining different approaches, synthetics, biological tissues, reinforcing structures to match the specific demands of different parts of a joint. Well, it could potentially be applied elsewhere. It's about tailoring the solution very precisely to the problem, isn't it? Food for thought, definitely.